Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Hello, grade 9 learners. Welcome to today's Natural Sciences lesson. My name is Mr. Stianda Madlala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, what are we going to do today? Today we'll be exploring the same strand, which is energy and change, but specifically under the topic electric cells as energy systems. And we'll be looking deeply into electric cells. That's all that you're going to be focusing on for today. All about electric cells. Now let's look at the lesson objectives. This is what you need to achieve by the end of this lesson. So by the end of this lesson, first of all, you should be able to explain that a cell is a system in which certain chemical reactions can cause the flow of electricity through an external circuit. That's what you need to know first of all about cells as electric systems. Secondly, you should be able to identify cells as a source of electricity. You should be in a position where you can be able to identify a cell as a source of electricity. And lastly, you should be able to describe a battery as a group of connected cells. And all that information, we find it under the CAPS document, page 73. Now let's move on. Let's look at what we have done in the previous grades prior to today's topic. So in grade 5, we have done an introduction to electric cells, right? We have done cells where we talked about the conversion of chemical energy into kinetic energy, right? We also have done mains electricity in grade 6. Not only that, we have done energy transfer in electrical systems in grade 8. And also have done what? Electric cells in grade 6. And we've done the national electricity grid in grade 7. So now let's move on. Let's look at this baseline activity now. So I want us to use this baseline activity as foundation to test how much we know so far about cells or electricity, right? So now, number 1, what is an electric cell? You need to tell us what is an electric cell. Number 2, what is the difference between a cell and a battery? So you need to list down the differences between a cell and a battery. Then number 3, what is an electric circuit? So now take about 4 minutes of your time so that you're able to write down the questions and answer the questions. See you after 4 minutes. Welcome back, grade 9 learners. Now remember, if you have any questions or comments on this lesson, we have our WhatsApp interactive number, which is 079-578-2908. Feel free to contact us on that number relating to this topic, right? So now, let's look at the solutions. Number 1, it says, what is an electric cell? So now, what is an electric cell? Were you able to answer that? And we define an electric cell as a system in which certain reactions can cause the flow of electricity through an external circuit, right? That is what an electric cell is. Then you give yourself a mark. Number 2, what is the difference between a cell and a battery? The difference is that what? A cell is a source of energy in a circuit, while a battery is 2 or more cells in a circuit, right? So now cell is source of energy in a circuit, then battery is 2 or more cells in a circuit. Now, number 3, what is an electrical circuit? And an electrical circuit is what? It is a closed path through which current can flow, right? So now, you have done your work. Probably you got some of the answers wrong, right? So I'm going to give you 1 minute to copy down the corrections. Welcome back again. Now don't forget our WhatsApp number 079-578-2908. Should you have any questions throughout this lesson, or should you have any comment, we are willing to answer to those questions and comments, right? So now let's continue. Let's look at the important terminology that is associated with this lesson. First of all, we have a cell. What did we say a cell is? We said that a cell is a component that converts chemical energy to electrical energy, right? It converts its potential energy to kinetic energy. Its potential energy is in a form of chemical energy, and it converts it to electrical energy, which is moving energy, right? We also have battery. What is a battery? A battery is a group of connected cells, right? So when you have 2 or more cells, you now have a battery. Number 3, we have electrical energy. And define electrical energy as energy resulting from the flow of electric charge. We also have what? Electrical charge. What is this electrical charge? It is a type of charge, whether it is positive, whether it is negative or zero, found on the particles of which all known matter is made. So now, the last one, we have potential energy, which is stored energy, right? So now, let's move on with our main meal for today. So today we're talking about what? Electric cells as energy systems. Let's dwell more on this, right? What did we say about this? We said that a cell is a chemical system in which certain chemical reactions can cause the flow of electrical charge through an external circuit, right? And we said that electrical energy is energy resulting from the flow of electric charge. So we use electrical cells to supply the energy needed for electrons to move around an electric circuit. Here's an example of electric cells, right? The ones that you are familiar with, the ones that we use to put in our remote for our TVs, right? Here's an example here, right? These are devices that contain potential energy or potential chemical energy that can be transferred into electrical energy, right? So that we can be able to have what? Electricity or a flow of charge in a second. So they are our source of power. So also about this, we said that an electric cell is a device that produces electricity, right? It is the main source of power in a circuit. It produces electricity. It converts that chemical energy into electrical energy. Are we together? So now, here's an example again. Your Duracells, your Evereadys, and so on, right? The ones that we are used to. It has the positive terminal and the negative terminal. I'm sure we have seen this before, right? They produce electricity because they convert what? Chemical energy into electrical energy. They convert to their potential energy into their kinetic energy, movement energy. So the chemical energy comes from a reaction that takes place inside the cell. So there's the reaction that takes place inside a cell when you have a movement of excited electrons, right? The reaction releases electrons that flow through an external circuit if the circuit forms a closed loop. Here's an example here again, right? So this cell here is this one here, right? So now this is an illustration of what is happening inside this cell. A lot of what? Potential energy is stored. It is stored in a form of chemical energy. So what happens here, right? There's some chemical reactions taking place, right? As you can see here, the electrons are excited, right? So that as soon as it connects with other components, that's when it starts to react. At this moment, it is still stored inside this system of a cell. It is in a form of chemical energy or chemical potential energy that is stored. So now, let's look at a system diagram to represent a cell, right? We have to look at the input, the process, and the output, right? So for input, what do we have? We have chemical energy that is stored inside a cell, right? That is when the chemical reactions are taking place. We have chemical energy stored inside the materials of the cell, right? And now, what is the process? It is input going to the process, right? So the process is that chemical reactions take place inside the cell and release what? Electrons. That's the process that is happening inside a cell. We have this stored potential energy, and the process that is happening here is in a form of chemical reaction where you have electrons moving and electrons being released, right? So what is the output? The output is what? We get electricity, right? We get electricity. Electricity is available to the external circuit. This is what we're talking about here, right? We have a cell, right? Now bear in mind, the cell that I'm drawing here, it is not in symbolic form in terms of what? The symbols of a circuit, of a circuit, right? It is positive, and this one is negative, right? So you have the input, the chemical energy that is stored in the form of electrons inside this cell, right? So in a system like this, or in a circuit, you have what? A light bulb and this cell, right? So you have this potential energy that is stored inside this cell. So what process are we talking about here now? The process of the movement of these electrons inside this cell. And they start moving from the negative terminal to the positive terminal. So what happens as they move here? There's going to be what? Electricity. Hence it says electricity is available to external circuit. So as it moves here with the conducting wire, it's going to light up the light bulb. And we have electricity. But we'll talk more about that in the following slides. So what is now the circuit symbol for an electric cell? Remember the first one I drew, it was not in a symbol form, right? Who can guess the symbol for a cell in a circuit? What is that? it looks something like this, right? It looks something like this. This is the symbol for a cell in a circuit. Are we together? So what happens here? We see many lines, right? Yes, this one is our conductor, right? So what happens with other two lines here? The other two lines stand for what? The long line stands for the positive terminal, right? It stands for the positive terminal of the cell. Whereas the short line or the short arm represents the negative terminal of the cell, right? Having these signs here. This one is positive, right? The plus sign is positive. And the negative sign is what? Negative is the negative terminal of the cell, right? So whenever you see a symbol like this, it represents a symbol for a cell in a circuit. Looking at these two lines, right? The long line represents the positive terminal, whereas the short arm represents the negative terminal of the cell. So now bear in mind, right? One cell has two lines, one long line and one short line to give us what? One cell. Let's move on. Moving on, we said that a cell stores chemical substances as potential energy, right? It stores its chemical energy as potential energy, which will later be converted into electrical energy or electrical kinetic energy. Are we together? So now when a cell is connected to an external circuit, the substances react with each other. That's when you start to have now electricity flowing in that circuit, right? This is because now the electrons are being released. So the reaction produces what? An electric charge with high potential energy, right? Here's an example here. Again. So now, bear in mind that this cell again is this one, right? There's a lot of potential energy in this cell. Hence you see what? The electrons moving around, right? So now I want you to look carefully at this switch, right? When this switch is opened, what happens? The chemical energy is still stored in this cell, right? It is still stored in this cell waiting to be used. And now the switch closes. There becomes what? A flow of electrical charge in that circuit, right? So remember, I said that they move from what? From the negative terminal to the positive terminal, right? So as it moves here, right? Now look carefully. When the switch closes, what happens to the ammeter now? It is able to get what? A reading, right? From 0 to 40 to prove that now there is what? There is a flow of electricity. It is now able to get what? A reading. Hence the input, the process, and the output we talked about, right? Now we have what? Electricity being visible or electricity flowing in our circuit, right? So now, moving on. We said that also the electrical charge which moves from the cell along conducting wires of the cell has kinetic what? Energy. It has high kinetic energy. It has high movement energy. This is because of what? The high potential energy it receives from the source of electricity, which is our cell. So electrical energy is a form of what? Kinetic energy, because it is moving. And the electrical charge with high kinetic energy moves from the cell to a resistor, for example, what? A light bulb. Again, now I'm drawing the cell in symbol form, right? Remember that this is our positive and this is our negative. So what happens here? When the energy is released from the cell, it moves along the conductors, right? Where is it moving to? It moves to what? To a resistor. Also, conductors are resistors, right? It moves to a resistor, but we'll use this one, for example, a light bulb. It moves so that it is where it is used, right? That electricity or that potential energy, which is now converted into electrical energy, is used by this light bulb, and this light bulb becomes lit, right? Because of what? Of the kinetic energy it receives, right? So now remember that they move from the negative terminal to the positive terminal. So we're going to explain this further again in the next slide. So now, here again, right, there is movement now of electrical energy, right? There's a lot of electrical energy moving to where? To this light bulb as a resistor, which is going to use this kinetic energy or this electrical energy, right? As you can see, this cell has what? 3 volts and the other one has 3 volts, right? So now this, because it is a series circuit, it means the total is 6 volts, right? So what's happening here? There's what? Kinetic energy in 6 volts moving along this circuit to light up this light bulb, right? So it moves from this negative terminal to the positive terminal again, right? So it is an ongoing process. Hence we said here, the resistor uses the kinetic energy to do its work. But now, before we get to that kinetic energy, remember our main source of energy, which carries this potential energy, right? In order for us to have kinetic energy, we must have stored energy first, right? So now, from that potential energy, which is converted into kinetic energy in the form of electrical energy, it is now used by a resistor to do its work, right? The resistor as an example that we used is a light bulb from the previous slide, right? And yet again, for example, the light bulb uses what? Kinetic or electrical energy to light bulb, right? To light up. Also your buzzers, your sound system, and so on, right? As what? As resistors that use kinetic energy or electrical energy. And the electrons re-enter the circuit and return to the cell, and this process is repeated many times, right? What happens is that movement from the negative terminal again to the positive terminal, it goes in and out like that again, right? The process is ongoing. Hence, this drawing here, right? It is that movement of electrical charge from the negative terminal to the positive terminal, and the process being ongoing every now and then, right? So the same energy is recycled in that cell. So now let's talk more about batteries now. What do we know about batteries? We said that a battery is what? It is 2 or more cells connected together in a system, right? So now, a battery is 2 or more cells connected together. Here's an example of a battery that we normally see, right? A car battery, right? Yes, you see a positive terminal and a negative terminal, right? But inside that battery, there's a lot of cells connected together to bring about this special battery, right? That produces more power, that contains more potential energy to give off more kinetic energy as well, right? Now here's a circuit symbol for a battery. Remember that I said one cell consists of one long line and one short line, right? One long arm and one short arm. So now what do we see here? We see now 2 of each, right? We see one long line and another long line. We see another short line and another short line here. This is to illustrate that this is what? A battery, right? This is positive, this is negative, this is positive, and this is negative. These are 2 cells connected together to bring about this one battery. Does it make sense now, right? It is 2 or more cells connected together, right? So now, I want us to engage in this activity before we move on. So now, the instruction here says, identify the following components of a cell, right? So because you need to draw this again in your class books, I'm going to give you 5 minutes, right? Identify the following components of a cell and label them. After that, we're going to do connections together. See you again after 5 minutes. Welcome back, lovely grade 9s. Now, remember our WhatsApp number 079 578 We're still waiting for those responses. We're still waiting for those comments as well, right? So now, remember we did this in grade 8, right? When we were doing components of an electric circuit. This is why this activity is here, right? Just to remind you. Hence, we said identify the following components of a circuit. So now I hope you drew them and you were able to label accordingly. So now, A. What is A? What is A? And A is our what? Our symbol for resistor, right? It is a symbol for resistor. Give yourself a mark. Then B. What is the symbol for? It is our symbol for a fuse, right? It is a symbol for a fuse. Then C. We just talked about it today, right? What is that? It is a symbol for a cell, right? It is a symbol for a cell. D, what is the symbol for? It is the symbol for a light bulb. It is a symbol for a bulb. Then E, what is that symbol for? Now remember there are two, right? There are two. But this one specifically is an open switch, right? For all of those who wrote switch, next time identify whether it is opened or closed so that you can get precise marks. So now, let's just take a minute to copy down the corrections and we are able to continue together. Now, let's carry on with our lesson. So now, let's talk about voltage. I'm sure this is not the first time you have heard voltage. Let me just remind you, right? Voltage is what? Is the marking on those cells, right? Cells have a voltage marked on the side, right? So now what is that voltage? Sometimes voltage is called potential difference, right? So now, what actually is this voltage? Voltage is a measurement of the amount of potential energy stored in a cell, right? So now, in order for a cell to be able to give off its energy in the form of kinetic energy, it needs to have some amount of potential energy stored, right? So now, it is usually marked on the sides of the cell, and it is sometimes called what? Potential difference. So now, who can identify the potential difference of this battery here? Who can identify it, right? Yes, it is that one, right? The 9V, right? What does the V stands for now? The V stands for volts, right? Meaning this battery or this cell has what? Has 9 volts as potential energy. Are we together? It has a voltage of what? 9 volts. So what do we use to measure voltage? We use a voltmeter. So we're going to talk about that in the next slide. So now, we said that the voltage tells us about how much energy a cell can provide to push a certain amount of electrons through a circuit, right? It tells us about the amount of potential energy that a cell has. Are we together? And it is measured in volts, right? It is measured in the unit volts. And we use a voltmeter to measure for voltage. So the higher the voltage of the cell, the more energy each electron has available to spend while it moves through the circuit, right? The higher the voltage of a cell, the higher the energy that is going to move along a circuit. Does it make sense? And we use what? A voltmeter to measure for voltage, right? So we measure the voltage by connecting a voltmeter across its terminals. But how? Right? Here is a picture to illustrate the testing or the measuring of voltage, right? Also, the voltmeter, it has two terminals. It has the positive terminal, which is the red one, and the negative terminal, which is the black one, right? So we place accordingly. Negative terminal to negative terminal of the cell. Positive terminal of the voltmeter to positive terminal of the cell. So that we can be able to measure the potential difference or to measure our voltage for each cell. Like this one here, after it has been measured, right, we get that it has how many volts? It has 1.564 volts as potential energy. Are we together? So now, let's move on to activity 2. Let's go through the questions together. Number 1 says that define the following terms. The term A is a cell. B is a battery. Then number 2, name one device that uses cells or batteries as a source of electrical energy. Then number 3, define an energy system. Number 4, draw the circuit symbol for a cell. So now this is quite long, right? Let's take 5 minutes to answer these questions. Then after that, you can be able to continue together. Welcome back, grade 9 learners. Now, I hope you were able to answer our questions, right? Let's look at the solutions together. Right. For number one was saying define the terms cell and battery, right? And here are our answers. A cell is a system that supplies energy to an electric circuit, right? Is a system that supplies energy to an electric circuit. B, what is a battery? It is two or more cells working together to supply energy to a circuit, right? Then number two, name one device that uses cells or batteries as a source of electrical energy. We have devices like laptops, our toys, our remotes, radios, clocks, watches, and so on, right? Give yourself a mark. Number three, define an energy system. What is an energy system? And we define an energy system as different parts that work together to store, to give, or use energy, right? To store, to give, or use energy. Then number four, draw the circuit symbol for a cell, right? And that is the one here, right? You give yourself a mark. Remember that the long line is positive and the short one is negative. So now, take 2 minutes to copy down the corrections. Welcome back, grade 9s. Now, let's continue with our lesson. So now, let's talk more about connecting cells. How do we connect cells? Before we start with that, what I can say to you now is that cells can either be connected in series or in parallel, right? They can either be connected in series or in parallel. So now let's look at the differences between the two. So now when we connect cells so that the negative terminal of one cell is connected to the positive terminal of the next cell, then we say those cells are connected in series because they follow each other, right? This is how they look symbolically, right? You have the positive and the negative. That is one cell, right? Connected to the other cell. To the positive terminal, the negative terminal of the first cell is connected to the positive terminal of the other cell, right? Then, for the following cell as well, right? The negative terminal of this cell is connected to the positive terminal of this cell, right? Now, how does it look in the form that we are used to, right? So here we have a cell, right? Positive and negative. So how can we connect them in series form, right? It means now the following one will be here, right? Where you have the negative terminal cell of negative side of this cell is connected to the positive terminal of the first cell. So this is cell number 1 and this is cell number 2, and in this case we have 3 cells connected in series, right? So also the other one will be connected to this one like this, right? Positive, negative. So now look at the statement there. When you connect cells so that the negative terminal of one cell is connected to the positive terminal on the other cell, we said that those cells are connected in series. They follow each other, right? Hence you can see here positive terminal of cell number 1 is connected to negative terminal of cell number 2. And positive terminal of cell number 2 is connected to negative terminal of cell number 3. So now, when we connect them in parallel, that's when now we connect the negative terminals of 2 or more cells together and the positive terminals of the same cells together. And therefore we say that they are connected in parallel. This is how, right? Hence you can see cell number 1, positive, negative. That is cell number 1. And we have cell number 2 again here, positive and negative. Then we have cell number 3 here. We have its positive and negative terminal as well. So now, look at this carefully. The negative terminal of cell number 1 is connected to the negative terminal of cell number 2. The negative terminal of cell number 2 is connected to the negative terminal of cell number 3, right? The positive terminal of cell number 1 is connected to the positive terminal of cell number 2. Positive terminal of cell number 2 is connected to the positive terminal of cell number 3, right? We can also draw this again, right? Here we have this cell, positive, negative, right? Positive and negative. Also, the last one, positive and negative. How are they connected together now? They are connected by these wires, right? They are connected by these wires connecting them together here, right? Now, can you see that the negative terminal of cell number 1 is connected to the negative terminal of cell number 2. And the negative terminal of cell number 2 is connected to the negative terminal of cell number 3. And as well as the positive terminals, right? Positive terminal of cell number 1 connected to positive terminal of cell number 2. Positive terminal of cell number 2 connected to positive terminal of cell number 3. So now, let's summarize what we have learned today. So today, what did we talk about? We're talking about what? Cells as energy systems, right? We're talking about electric cells. And we said that electric energy is energy resulting from the flow of electric charge. But where does this electrical energy comes from? It comes from what? A cell, right? It comes from a cell, which is a device that converts chemical energy into electrical energy so that we are able to have electricity, right? So a cell is a chemical system in which certain chemical reactions can cause the flow of electrical charge through an external circuit. So, and we said that we use electric cells to supply the energy needed for electrons to move around an electric circuit, right? So now having an electric circuit and we have a cell, right? And we have a cell with this positive terminal and negative terminal, and this is the whole circuit with a light bulb, right? We use this cell, right? We use this particular cell to get what? Electrical energy, because they supply what? Electricity, or they convert their chemical energy to electrical energy. They convert their potential energy to moving energy, which is kinetic energy. From there on, with their potential energy stored inside here, when they react with other components such as wires and other resistors, there is now what? Some reaction and the flow of electricity, right? Now they produce electricity and this light bulb becomes lit. We also said that a cell stores chemical substances as potential energy. I've just mentioned that one, right? So when a cell is connected to an external circuit, the substances react with each other, as I have said. Right. We also talked about potential difference. What is this potential difference we're talking about here? It is what? Voltage. But what is voltage, right? We said voltage is the measurement of the amount of potential energy stored in a cell, right? So now, who can identify the potential energy of this cell? Let's take a minute so that we can get answers from you guys, right? Identify the potential energy in this cell as an example. Take a minute. Hello, grade 9s. We're still waiting for your responses or comments, right? Our number is 079 578 Now, I give you some tasks, right? Identify the potential difference of this battery, right? Identify the voltage of this battery. And now, the voltage is what? It is 9 volts, right? Then, if you got yourself a correct guessing, give yourself a round of applause, right? Because this is the correct one. It has 9 volts, right? It is the amount of potential energy or the potential difference in this battery or cell. Are we together? And we said that it is measured in volts. As we can see here, 9V. Now moving on with our summary. We also talked about the difference between a cell and a battery, right? What did we say the difference is? Yes, we said that a cell is a component that converts its chemical energy into kinetic energy, right? Chemical energy into electrical energy. And we said that a cell looks something like this, right? All the cells that you know of, your Duracells, Energizer, Everready, and so on, right? And we also talked about what? A battery being what? 2 or more cells connected together. Now, just to remind you, a cell is a single component that converts what? Chemical energy into electrical energy, right? And it is symbolized like this, right? It has one long line and a short line here, right? And those lines represent what? The long one represents the positive terminal of a cell. And the short one represents what? A negative terminal of the same cell, right? This is one cell. This is one cell. Are we together? It has a positive terminal and a negative terminal. Now, what more about a battery? A battery, we said that it is 2 or more cells connected together to supply electrical energy. And here we have what? A battery in a form of symbols, right? So now, it means it is something like this, right? We have one cell here having the positive terminal and the negative terminal. That is one cell, right? Hence you can see here, one positive, one negative. That is one cell, right? Then you have another cell connected to it here, right? It also has what? A positive terminal and a negative terminal. Now these cells, now there are two, right? They are in plural form. They are two. And we therefore say now it is what? A battery, right? So now, looking at this, just to remind you, I told you that one cell has one long line and one short line, right? That is one cell. So now if you count here, how many long lines do we have? How many short lines do we have? We have two of each, right? Two long lines and two short lines. Therefore, it stands for one battery, right? Now it is two or more cells in this system and it stands for one battery. Are we together? And we said, we talked more about connecting cells again. What did you say about connecting cells? We said that they can either be connected in series form or in parallel, right? So when we connect cells so that the negative terminal of one cell is connected to the other positive terminal of the other cell, right? We said that they are connected in series, right? They are connected in series form. They are connected in a way that they follow each other like this, right? Positive, negative, and we have another positive and a negative. Are we together? They are in series form. But when we connect the negative terminals of two or more cells together and the positive terminals of the same cells together, we say that they are connected in parallel, right? They are connected in a way that they are in parallel form, like this, right? Here we have these cells here, positive, right? And negative, 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 right? They are connected in parallel. Are we together? Also here, they are connected in parallel. So now, let's meet again on the next lesson when we're talking about resistance. I hope you have enjoyed today's lesson. I hope you keep on respecting others, and I hope that you write your homeworks. From me to you now, thank you and goodbye.